All right, so this is example 1. We're going to be looking at solving exponential equations. So there's going to be 2 of these, and these do match what you have in your book. All right, for A, we see that we have 100 to the x power is equivalent to 1/10 raised to the x minus 3 power. Now, what the core concept that you've seen in the prior slide, that property of equality for exponential functions, means that if we change it to the same base, say we have the same base of 3, we can go ahead and cancel that base out and just look at x equals 4. Now, that's an example. In this case, we see that we have 100 to the x and 1/10 to the x. We are going to need to rewrite this in order for them to have the same base. Now, you hopefully can see that they both are in the family of tens. So we're going to go ahead and rewrite it with a base of 10. So 100 is 10 squared. So we're going to call that 10 squared raised to the x. All we did was we substituted that 100 for 10 squared. Now 1/10 is 10 to the negative 1 power. And then we've got x minus 3. Using the power property, we're going to go ahead and distribute both of those. So that turns to 10 to the 2x equals 10 to the distribute that negative 1, negative x plus 3. And because of that core concept, that property of equality for exponentials, that is a proved theorem, it says that we can go ahead and cancel out that 10 bases, and it's going to turn to 2x equals negative x plus 3. We're going to now solve this like a regular problem. We've got 3x equals 3 and x equals 1. And that is it. You can also go back and check it. But at this point, unless it says check, I won't require you to. All right, that is A. A is a little on the easier side than B. So let's take a look at B. B is 2 to the x equals 7. So we just talked about the equality property. This one doesn't have that, because we can't take 7 and change it to a perfect power of something, right? No, we can't do that. So we're going to have to go ahead and figure out how we can get x by itself. Well, if we go ahead and just do our regular rewrite, we can go ahead and rewrite this as log base 2 of 7 equals x. Then you'll want to go ahead and do the change of base. We have log 7 over log 2 equals x. Plug that into your calculator, and you should get x to be around 2.807. I'm going to use approximately. Now, there's another way that you can go ahead and do this. The book describes it as taking the log base 2 of each side, whereas we go ahead and do the rewrite. Those are equivalent, so if you look at both ways, both of them work. I tend to stick with this one because it is more cohesive with our other sections.